Hi class, welcome to lab number 7, managing data. Before we get to work on lab number 7, we're gonna go over the practices from the lecture presentation. So to start with practice 1, we need to download this script and run it, but we're gonna do that in a single command using curl, and then we're gonna pipe that into bash. So let's do curl. This script is going to start a couple of software in your computer, so if it takes a little bit, just give it its time. Now that it's done, let's move along to instruction number 2. Change your current working directory to practice 1. So we're going to do cd managing data practice 1. Perfect. Let's clear our screen, and then we're going to create an archive called fortunes.tar. So let's do tar. Let's take a look at what's inside the directory first. Let's do tar, create, and then the file, which is fortunes.tar, and then we want everything inside the present working directory, so I'm going to use a star wildcard to make my life easier. Now we're going to remove all the files except fortunes.tar, and if you do an ls, you're going to notice that these files have some things in common, like this one is fortune -3, fortune -1, but this one is fortune -2. So I'm gonna make my life easy, and I'm gonna use a wildcard for this. So I want everything that starts with letter F, has letter O or letter U after letter F, so then it has letter RT, a star, minus, and then it has a number. As a matter of fact, I can just use another star and color the day, right? You know, fortune is gonna match fortune is gonna match fortune, and it's gonna match fortune, and then it's gonna look for a hyphen between anything here, and then it's gonna look for whatever else is after the hyphen. This eliminates fortunes.tar. It doesn't qualify anymore. So let's press enter, and if you do ls, notice fortune.tar, you know what's there. You don't have to use a wildcard if you don't want to, but I want you to get used to using wildcards because they make your life easier. You can delete them one by one if you so feel like. Okay, so now that we've done that, let's move along to number 5. List all the members of the archive, and notice the wording that I'm using here. List all the members of the archive. I'm using the word list. That doesn't mean that you're going to type the ls command, because I'm not talking about the files inside the folder. I'm talking about what's inside this box. Show me what's inside this tar ball. And for that, we're going to use the tar command. So that would be tar tf, because option T allows us to see what's inside the box. And then fortunes.tar. Yay. Perfect. Now we're going to create a new file, and we're going to put some data in it. So I'm going to use vim for this, right? So we're going to use vim new file.txt, and I'm gonna say Linux is awesome. Awesome, right? And now that we have Linux is awesome over there, we're gonna add that file to the box, right? We're gonna grab the file and save it in the box. How do we do that? Tar R, because we're adding a new file, F, fortunes.tar, and then the file that we're adding, which is new file.txt. Press enter, and if you list the contents of the archive one more time, notice that new file.txt has been added to our box. Perfect. Now, add the new file.txt to the archive. You already saw how to do it. Add more text to new file.txt and update the archive. Perfect. So we're gonna do vim new file.txt, and let's say I do not like Windows very much, right? I didn't quit. Oh my god. rm. I created that at file by mistake over there. So now we're gonna add this file to fortunes.tar. Okay, so we're gonna add this file over here to fortunes.tar. Sorry, I had to pause there for a second. Okay, so now how do we update this file? Because new file now has a new sentence there, right? So this file is the newest version. This is the old version of the file, right? So if we want to update what's inside there, what we have to do is use the U option. So we're going to do tar U fortunes.tar and then new file.txt. And that takes care of updating what we have in the tarball with what we have outside. Perfect. Now we're going to remove that new file from there. So in order for us to remove a specific member of an archive, we need to use the delete option. So we're going to do tar delete and then F and then the tarball, which is fortunes.tar. And now we need to specify which member we're getting rid of. We're getting rid of new file.txt. Press enter. And if we do tar -t f fortunes.tar, notice that new file is finito, is gone with the wind. Okay, now option number 10, we're going to create a new directory called newdir, and we're going to extract the files inside newdir. So let's take a look at this. Let's do the easy part first, which is mkdir newdir. Okay, so now we have a new directory called newdir. What I'm asking you is extract this archive, right? Take what's inside this box and put it in here. Now, there are a couple of approaches you can take. You can move the archive to newdir and then extract it over there, or if you look at the man page, you could actually use an option of the man command that allows you to extract archives in a different directory other than your present working directory. And for that, we're going to use tar extract file, and then the file we're extracting, which is fortunes.tar, and then we're gonna use option F, so option C, capital C, right? And then we're gonna specify the directory where that's going. This is going to new dir. Press enter, and if you do ls new dir, notice that we have in there the files of our archive. Okay, so that's practice 1. Practice as much as you can, and let's move along to practice number 2. So in practice number 2, we're going to be working with the cpio command. What I'm going to do is that I'm going to clear my screen over here, and instruction number 1 is run the following script, but we ran the script already, so we don't have to do it again. Okay, so I'm not going to do it one more time. I already did it, right? I put it in there because, you know, maybe later on you want to practice one of them independently and doing it in different days, so you don't have to, you know, move around different practices. But we already did practice 1 and we have this information, so we don't need to do it again. So I'm going to jump straight to number 2. Change your current directory to practice 2. So I'm going to do cd, 2 periods to go backwards, and then practice number 2. Now that I'm in practice number 2, I'm going to create a new archive, right? And this is going to be a cpio archive containing practice 2. Everything is our practice 2. Now, the trick about cpio is that cpio only works with list of files. So we need to generate a list first. So if I do ls, this is going to generate the list of files, right? I have all the files over here. Now we need to pipe that to cpio, right? So that list gets sent to cpio as an input. So we're going to do cpio, and then we're going to do options O and V, and this will allow us to create an archive, right? So OV for creation, and then the name of the archive, right? No. Here's the thing. We gave cpio a list of files. If you just type the name of the archive over here like you do with tar, it is not going to work. We need to actually redirect this to a file. And this is going to be called nature.cpio. Press enter, and you got it. Now, question number 4. Remove all the files except nature.cpio file. So let's do ls. Okay, sorry, zooming a little bit more. And then I need to get rid of nature 1, nature 2, nature 3, right? Okay, well, rm nature -star enter. Done. Now, extract the archive and create a new archive including only nature 2 and nature 3. Now this is an interesting one. Let's extract this, right? Let's do the easy part, right? Extraction. So to extract an archive, we start with cpio, right? And we provide the options I and V for extraction. And now we need to also redirect one more time and then say, okay, what are you extracting? I'm extracting nature.cpio. If you press ls, notice that we got all our files back. Now, we want to create a new archive that only includes nature 2 and nature 3. So the trick here is first finding the ls command that's going to list nature 2 and nature 3, but that's going to be easy. ls nature hyphen, right? And then we're going to use a wildcard to include only number 2 and 3. Press enter and notice that it only includes number nature 2 and 3, right? So now we're going to pipe this into CPIO, right? And then provide the options O and V, right? Let me zoom out a little bit so you can see the whole command. And then we are going to do output redirection to the file that we're creating. And this is going to be called, did they give us a name for it? And no, so I'm going to name it whatever. I'm going to say not other. .cpio. Press enter, and let's type ls. And notice that we have nature and we have a not other CPIO. Let's move on to number 6. Create a new file called newfile.txt. Add some text to it. Create an archive including newfile.txt and previous archive. So we're going to create an archive that includes nature CPIO, not other, and the new file that we're going to create, right? But this has to be a tar archive, right? So let's approach this the simplest way possible. Let's do the easy part, which is creating the new file. So I'm going to do vim new file.txt, and I'm going to say potatoes are in nature. Done. Now, how do we generate a list of nature, not other, and new file? Well, I can do ls star cpio, right? So this is going to include all the files that are cpio files, right? And then I'm also going to do give me new file as well. And notice that it lists the 3 files that I'm looking for. Now I can create the archive. Let's pipe this to CPIO, options OV for creation, and then output redirection, and then we're gonna call this one of, let's see, new archive, new arc.tar. However, this is not gonna work. You see, we were working with CPIO files before, which is fine, but for tar files we need another option. So let's go back and backtrack a little bit. So OV allows us to create CPIO archives. But what option will allow us to create tar archives? For that, we need to provide option H and F. Press enter. We don't need the output redirection in this case. Oh, I think I made a typo here. I need to specify, there you go, I need to specify that I'm creating a tar archive with tar. Too many arguments. Wow, I use CPIO so little that I'm even forgetting this. Oh, wait, hold on. I think I just had a typo there. There you go, I just had a typo over here. I'm normally a tar person, so I don't use CPIO that much. Although CPIO, I use it frequently only when I'm writing scripts for backing up stuff. Other than that, I prefer to use tar. So if a couple of the options escape me, I'm a human being, pardon me. So I'm gonna type ls here, and notice that our new archive has been created over here, new arc.tar. Okay, list all the members of the archive, and no, you cannot use tar. You have to use CPIO for that. And in order for us to see what's inside this box, we need to provide a couple of options to CPIO. So let's do CPIO first, right? And then we're gonna do IT and then capital F. And then let's do the name of the archive, which is new arc.tar. Notice this shows us what's inside the archive. Again, CPIO is much more complex than tar. It takes practice, and it takes a lot of usage. As you can see, look how much I started, for instance, just doing this practice on my own, because CPIO is a little bit more complex, it's a little bit more nuanced than TAR. That doesn't mean it's less powerful. It is as powerful as TAR, probably even more. It just takes a little use to it. Practice this as much as you want. It's not gonna be in the midterm if you were wondering that, but it is important to know. Let's move along to practice number 3. And number 3 is just talking about the R utility, right? And this is actually very, very simple. So, same thing. Let's go to practice number 3. So I'm going to do clear, and I'm going to do CD, back, practice 3. Now that I'm here, using R, create an archive of all the files inside the practice 3 directory. Do we have anything in here? Let's see. Okay, so if we're going to use R, it's actually very simple. So I'm going to do R, and then the name of the archive, which is, they didn't tell me what to name it, so I'm going to name archive.a. That's the extension for the R command. And then the files that I'm archiving, and in this case, I'm archiving everything inside practice 3. Press enter, and I'm done. If I type ls, notice that I have a new archive called archive.a. Okay, so next, list all the content of the archive. And to list, rt, and then archive.a. Done. Create a new file, add some text to it, and then add it to the archive. Vim, new file, .txt, let's say, archiving is cool. Okay, right, and quit. And now let's gonna add that to the archive, right? So in order for us to add to the archive, all we have to do is to r that's funny, archive, and then the file that we're adding, which is new file .txt. And if we want to list, notice that new file.txt has been added. Now, list all the members of the archive. We did that. Delete the new file in the archive, and for that, all we have to do is provide option D, and it's done. In the midterm, if you want to use R or if you want to use TAR, it's up to you. I suggest you stick with TAR. Okay, so with that said, there is nothing to practice on file compression because these commands are straightforward. So let's move along and explain lab number 7. Okay, so lab number 7, managing data. For this lab, we are going to be using this script over here. So use curl, pipe it into bash, and put in your password in there because it's going to install a couple of programs that we're going to need for this, especially these guys over here. So we're going to be using fmpeg, zip, libtex, lorem perl, 7zip, and unrar. Okay, the script will install all the necessary packages, but if you have any issues later on, just make sure that the packages are installed. So let's move along. Let's clear the screen. Let's do ls, and notice that you have a new folder called lab number 7. So let's go inside lab number 7 and take a pic. So inside lab number 7, we have questions 1 to 4. So question 1. In the questions 1 directory, you will find a bunch of files. Create an archive called all files that includes all the text files, all images that have a number in their file names, and all video files. Okay, so if we're gonna go to question 1, let's take a look what's inside here. So we have 1, 2, 3 text files and 4 text files, and we have a video.mp4 file, right? So I don't see any images here, but let me do an all to make sure that there is nothing hidden over here. So, okay, so there is nothing hidden, so I don't know why I included this over here, so that's probably a mistake. Let me pause the video and take a look at the script real quick. There you go. Yep, there was a little mistake over there, but I fixed it already, and now we have all the files that we need. Perfect. So let's continue with question 1.tar. I was missing one of the programs here that was required, and I missed it in the script, and it didn't install, therefore the files were not generated. But by the time you're doing this, that's gonna be fixed, so you shouldn't worry about it. Now, so we need to create a tar archive called all files.tar that includes all text files, all images, and all video files, right? So now, you know what? I'm gonna do it. Why not? So we're gonna do tar. Oops, sorry. There you go. right? I'm gonna do it and I'm gonna explain it, right? So that's because that's a little better. So obviously tar cnf, right? And then the name of the archive, which is all files.tar. Now, this is when we need to start paying attention because now we need to be a little bit more specific. First of all text files. How do we target all text files? Well, simple. Start.txt, right? Start.txt. That one was easy. But now, all the images that have a number in their file names, right? So it has to have a number somewhere in their file name. So what would be the most effective way to target all the files that have a number in their file names and at the same time, are images, right? Because if you take a look here, we have SVG, we have JPEG, we have PNG. So what kind of wildcard can we create that will target all of these files? Because obviously we can type them all together, but we want to be pros here. We don't want to do things the beginner way. So definitely, we want 89 berries, banana.png, and we want pineapple.89. And this is a JPEG, this is an SVG, and this is a PNG. So I know for a file, right, that I'm gonna have JPEG, I'm gonna have PNG, and I'm gonna have SVG. That takes care of the file extension. And let's put a period over here because we're gonna need that. Perfect. So I know it's gonna end in one of those three, so I'm targeting those threes. And it has to have a number in the name. The number can be at the beginning, can be can be at the beginning, can be before the file extension. So in other words, the number can be in the middle. And if we have the star wildcard that can match any characters, no characters or multiple characters, right? So it can match 89, right, at the beginning because it matches nothing before 89 and everything after 89. So that's good, right? But the question here is, how do I then represent numbers, right? How do I represent numbers? How do I represent alphanumeric characters, right? So, one second, guys. Okay, I'm back. Sorry about that. So, again, as I was explaining, so how do we represent the numbers? Well, if you go back to our lectures on wildcards, you're going to remember that we have something called meta characters, right? And we have what was called the reg expressions, right, as well. But we can simply use, hey, the brackets wildcard, right? Give me any digit between 0 and 9. And since we're looking for anything that has a number in their name, and I don't care if the number is at the beginning or if it is in the middle, all I want is that it has a number in its name. But we also need to provide the star over here, because if we don't, then it's only going to be looking for number at the beginning. And we don't want that because, for instance, we want to match 89 here as well, 89 over here and 78 over here. So that takes care of the pictures. And then the video, but the video is just a single file, so we can just simply do video.mp4. Now, press enter, and now let's list all the members of that archive and make sure that our stuff work as it was intended to work. So let's do tar minus tf, right, to view the members of the archive, and then do the name of the archive, which is allfiles.tar. And as you can see, we have pineapple 89, banana 78, and 89 berries, and we also have all the text files, and we also have video.mp4. Okay, create another text file with some text. Use the command lorem to generate the text, and then save the output with redirection to save it to a file. Now you should have the program lorem already installed in your system. So if I do lorem, it will generate random data. Right, so let's clear our screen. Don't forget to take a screenshot before you clear your screen. So let's clear our screen, and if you type lorem, and I'm gonna send that, and I'm gonna call this, I'm gonna save the output to random. Do they tell me what to name it? Nope, they did not. Random text.txt, right? And if you do cat random text, it is the content of the output of the lorem command, right? If for some reason you couldn't install the lorem program, right? When you ran the script, it gave you an error and now it doesn't run. You can always use the curl command, right? And then call, hit this endpoint over here that is going to automatically generate the number of paragraphs that you specify. So if I run this command over here, it's going to give me five sentences, um, 5 random sentences. That's what it's going to give me, right? And I can save that to a file called sentences. If I do ls, notice I have a file called sentences.txt over here with the output of the curl command. Okay, so that is in case the lorem command didn't work for you, but I'm pretty sure it will. So let's clear our screen and let's move along. So create a file and then add it to the archive. I'm not going to show you how to do that because we already went through that, right? We did that when we were doing the examples, and you have plenty of examples to that. Add the new file to the archive. Not going to show you how to do that. You already know how to do that, and you already know how to do that. So let's move along with CPIO. Move the all files that are archived from question 1 to question 2. Okay, so it's gonna do what I'm gonna do is that first I'm sorry, you know what? I'm just gonna do the mv command directly from here. So I'm gonna do mv all files that are, and obviously yours is gonna have more files than mine because you did the entire question 1. I only did part of it, and we're gonna send that to let's go back one directory and let's go to question 2, right? And now let's do cd question 2, right? And then in here we're gonna have the all files that are. So now we're gonna extract this in our present working directory, right? And for extraction we need to use the CPIO command, right? Because that's what we're using here in question number 2. We're not using the tar command, we're using CPIO. And as you remember from the presentation, in order for us to extract an archive, we need to use INV. So CPIO minus IV, right? And then input redirection in this case, and then all files that are. Type ls, and notice that we have all of our mumbo jumbo over here. Remove the archive and create a new archive with CPIO of all the files. Okay, rm done. Now let's create a new archive. And for creating a new archive with CPIO, remember we use the OMV option. But first we generate a list of all the files that we want to archive. And since I want everything in my present working directory, all I'm gonna do is type ls. And then we're gonna pipe that into CPIO, right? And then we're gonna provide the options, which is OMV. And then we are going to redirect the output to the file that we want. And in this case, they gave us a name. No, so I'm gonna name it whatever. What do I name this? I'm gonna name it all my files. All my files. That's CPIO. Press enter, and you're good to go. Type ls, and you have a new file called all my files.cpio that contains all the files inside your present working directory. So now create a tar archive with CPIO. Oh, sorry, I created a CPIO archive. I'm sorry, I did the wrong command. I misread it. I created a CPIO archive. So why don't we create a tar archive now, right? So let's create a tar archive, which is the real answer to that question. And for creating a tar archive, it's a little bit different, right? So the first thing that we're gonna do is again generate the list of files, then send it to CPIO, and then we're gonna provide a combination of options, starting with OMV for creating the archive, and then capital H, and then the type of archive that we're creating, in this case is tar, and then letter F for the file that we're going to put everything in, and in this case it's called all my files.tar. If you type ls, look at your tar file over here. Okay, so remove all the files except the tar archive. Okay, everything except the tar archive. Then how do I do that? How do I get rid of everything except the tar archive? You know what? You take care of it. I'll let you do part number 3. Right? Question number 4, because it's very easy. Go ahead, you do it yourself. You can take multiple commands if you want, or you can find out a wildcard or a combination of wildcards that can do the job for you. So extract the archive using CPIO. Not gonna do that one. You saw an example earlier. I'm gonna let you do it on your own. Okay, so let's move along to question number 3. We're using gzip, bzip2, and xz. In the question 3 directory, you will find one file called my notes.txt. Okay, so let's go there. cd, bang bang, go back, question 3, and we are here. Okay, and no, there is not a file called notes.txt. So you know what? Why don't we create it? Let's use lorem, right? Let's use lorem, and then let's send that to my notes.txt. That probably my notes.txt. That's probably a mistake in the script, but I'm not gonna fix that one. I already showed you how to generate a random file, and we're gonna work with that file. So what is the size of this file? So how do you know the size of this file? Now there are multiple ways you can do that, but the simplest one is just using ls. I'm gonna use ls and then minus l for doing, long listing, and then I'm just gonna do h for human readable, right? And then press enter. And what's the size of the file? It's 183 bytes. Something very small, right? So you know what? I want to make it a little bit bigger. Why not, right? So I'm gonna do lorem one more time, and I'm gonna do it again. And you know what? I'm gonna do it again. I'm gonna do it again 3 times, right? A little bit bigger, right? Wow, it's still very small. So why don't we do, yeah, right. Why don't we send a couple of sentences there? Again, I'm just creating a file with a bunch of data. You can do the same thing I'm doing, or you can do something else as long as you put a bunch of text in there. Because we want at least a couple of megs, right? At least 2 kilobytes, right? Something that we can see, something that we can work with, right? So I'm gonna do 5 sentences. No, give me 100 sentences, and then save that into my notes. Right? There you go. And let's see the size. There you go, 7.2K. That's a little better to work with, isn't it? So, great. Now, we're going to compress the file using all these 3 functions, right? But we need to keep the original file, right? So, because we don't want to get rid of the original file. So, let's do clear, and let's do, let's start with gzip. So, let's do gzip minus k to keep, and then the file done. And then let's do the same thing, but let's do bzip2 in this case. So let's do bzip2 minus k my notes. And let's do xzip minus k my notes. Perfect. Now long list all the files. Which tool gave you the best compression? ls minus l h, right? Enter, and then compare everything. And in my case, they are all 3.0 Ks, right? They're all the same thing. Now, if you want to play around with this, why don't you try with a picture? Or why don't you try with a video? Why don't you try with an audio? Or with a different type of file? Whatever file you want to use in this question, that's fine. I don't particularly care. I want to see you using the commands. That's what I'm going to grade you upon. So you don't necessarily have to do what I did to generate my notes file with a bunch of stuff. You can literally just grab a file from the internet and play around with it. Whatever you want to do, I'm happy with that. As long as I see that you use the commands and that you understand them, you get the grade. Okay, so for question 4, we're going to decompress all the archives that we have on question 3, so all of these guys, in the question 4 directory, right? So let's move along and do cd question 4, and over here we're gonna decompress the file. So remember that for decompressing we use option D. Now here's the thing, gzip, these guys, gzip, bzip2, and xz will not be able to decompress the file directly just by you providing the present working directory as an archive, because they will, if you do this, gzip, oops, sorry, there you go, gzip question 3, and then my notes.gz, this is gonna decompress this is gonna decompress the file in the question 3 folder. It's not gonna decompress it in our present working directory, right? So the question here is then, how can I decompress the file in my present working directory then? Because that's what I wanted, right? I wanted, because what if I have a compressed archive in a flash drive, and I want to decompress it in my home computer? Do I have to copy the file and then decompress it? That is too much work. But this is where output redirection comes in. Our input and output redirection comes in, because what we can do is we can provide option D, K, and C, right? So D, K, C, these 3 options, and then say, hey, look, take this as an input, right? Take this file as an input, gzip. Take this file as an input. And as an output, I want you to take whatever you decompress, put it in this directory, which is our present working directory. The only caveat here is that you need to provide the same name to the file. You can just decompress and rename at the same time. So my new file in my current working directory needs to be named mynotes.txt. So I do mynotes.txt. And if you press enter, notice that you will have my notes file in your present working directory there. Now, let me get rid of that my notes tool, rm my notes tool, so we don't need it. And now, my notes.txt. I'm gonna rename this file because I'm gonna decompress with bzip2 the other file, and I don't want it to conflict with the same file name. So I'm gonna do mv my notes2. Done. Now, literally the only thing that I need to change is the program. bzip2, and the options stay the same. D, K, and C stay the same. They will do the exact same thing. So I'm gonna press enter. Oh, sorry, this is not a bzip2 file. There you go. That needs to change too. Sorry. Press enter, and now I'm gonna rename my notes .txt, and I'm gonna name it my notes3.txt. Why not? Done. Now I'm gonna do the same thing with xz. Change the file extension here because we're dealing with xz. And change the program as well. Press enter, and now if we do ls, you have your 3 files over here. Now, in accordance to question 4, you're gonna use zip to create an archive of the 3 files, right? And then you can go to the presentation and find the answer to, find the command that you're going to use for that over there. I'm not going to do it for you because the example is very clear in the presentation. You're going to use 7-zip to extract, to archive all the files. So you're going to create a 7-zip archive, right, of all the files as well. That will include the zip archive that you will create. So a 7-zip archive of everything, right? Again, this one is not as clear, but I want you to try to crack it on your own, right? But if you can't, just shoot me a message and I can show you. But I want you to try it on your own using the examples that we have in the presentation, right? I want you to give it a shot. Now, create a RAR archive using 7-zip, right? Because with 7-zip, we can create RAR archives in Linux, right? Again, there is a perfect example on the presentation that I want you to use to try to tackle that one, right? And long list all the archives, which ones gave you the best compression ratio, right? Now, this one over here, again, obviously, this, if you want to skip it, it's fine. It's just a long list command. I don't particularly care for this question because I want you to include everything in each and every one of this. So obviously there is gonna be a difference in size. So if you want to skip question 5, it's fine. Or if you want to do it, it's just an ls command. It's an ls -l command. It's not gonna. It's not nothing new that you haven't done. I'm more concerned about 2, 3, and 4, because that's what's new. Because I already showed you how to do number 1. With that said, this concludes that number 4. Practice, practice, and practice so that you can become a command line wizard. See you next.